Before we go into area of segment, let us take a quick revision on arc length in radian mode as well as area of sector in radian mode. In radian mode, we know that the arc length formula is actually r theta, while in radian mode, the area of sector formula is half r squared theta, where theta is actually representing the radian, the angle in the center, and r represents the length of radius. So if I'm given the arc length of 6 cm and I'm told that the radius is 4 cm, I will know that my angle at the center, which is my theta, is actually 6 over 4, which is the same as 3 over 2 radian. Knowing that the angle at the center is 3 over 2 radian, I substitute into my area of sector formula. I'll be able to calculate that my area of sector is 12 cm squared. Alright, where I get half times 4 times 4 times 3 over 2. The other side of it, if I'm given area of sector this time at 0.75 meters squared, and I want to calculate the angle of sector given 1.5 meters. So if I know that my formula, alright, for area of sector is half r squared theta, and I know that my r is 1.5, so I would have been given, and if I do my substitution, I know that I must take my 0.75, which is the 3/4 meters, divide by my r square, which is 1.5 times 1.5 times my theta. Alright, so this in turn will give me an answer of, let me write it in a different color, 2/3 radian. Alright, and now that I know the angle at the center is 2/3 radian, to calculate my arc length, I just need to take my 2/3, multiply by my radius, which is 1.5, 3 over 2, so I will then therefore get 1 meter. Given angle at the center, given arc length, go calculate your radius, you should be able to get 8 cm. How to? Take your arc length divided by your radian, divided by your angle, which is 2.5, so 20 divided by 2.5, you get your 8. Now for such questions, if things comes a little bit more complicated, remember, write out the entire formula, fill in the information that you have, and then do your algebraic manipulation. Alright, so with the radius, I am able to calculate my area of sector, that's half times 8 times 8 times 2.5 to give me 80 cm squared. Now what about this case in part D, where arc length is given, area of sector is given, oops, no radius, no angle at center given to you. Then how to do that? Now we see that my r theta is equals to 5. Over here in the formula, I know half r squared theta is equals to 6. If I rewrite my half r squared theta, I can write it as half times r, oops, maybe too small. Alright, times r, because it's r squared, times theta is equals to 6. I have an r theta here, and that r theta is as good as 5. So I know it is 5 over 2 times r is equals to 6. So therefore my r, upon calculation, my radius will give me 2.4 meters. Knowing what the radius is, therefore, go calculate angle at the center. With either of the formula, you should be able to get to 1 over 12 radian. With this quick revision on arc length and area of sector, let us now look at a segment. What is a segment? A segment is formed when a chord is drawn between two radii of a sector as shown below. So you see this, alright, this slice here is known as a segment. Alright, this is a sector, and this obviously is my triangle. So I can see that my segment essentially is one sector. I take away the yellow triangle. The pink segment is actually my entire sector, taking away my yellow triangle. Knowing what is the formula for area of sector in radian mode, I get half r squared theta. And then knowing what my area of triangle is, using my trigo rule, that's half r squared sine theta. Alright, if I simplify this formula, I will get the formula for area of segment, half r squared theta minus sine theta. Do note that this theta here is in radian mode. If it is in radian mode, please remember to change your calculator mode to radian mode before you do any form of calculation. I repeat, since the angle given to you is in radian mode and you want to calculate everything in radian mode, please remember to change your calculator mode from degree mode to radian mode. For those of you who are not familiar on the change, you can of course refer to your calculator manual. For those of you who are using Sharp, I think some of us, we have been talking about this mode 3, mode 3.2 or mode 3.3 when we saw quadratic and cubic. For this calculator, you need to go to setup. Alright, and when you go to setup, you will see DRG. Go to DRG and then choose radian mode instead of degree mode. Knowing the area of segment, let us use examples to show how to do calculation. Now, if you look at the example at the bottom of page 10, you will see that the area of the shaded region, the pink region there, in my video, in my diagram, alright, we want you to find the area of the pink region. The pink region is given to you with radius 15 cm and angle 100 degrees. Alright, maybe for the context of this question, I'm just going to use radian to do it. Of course, many of you will be able to solve this in degree by just finding the area of sector in degree. Alright, then finding the area of triangle in degree mode. So my point of emphasizing is if you decide to solve the entire question in degree, then do it in degree. But if you decide to solve the entire question in radian, solve it in radian. Both radian and degree mode will give you ultimately the same answer. Let me do this in radian mode for you. First and foremost, we know that 100 degrees is equals to pi radian. So if I have, 180 degrees is equals to pi radian. Therefore, if I have 100 degrees, it is as good as 100 out of 180 degrees times pi, and that will give me 1.7453 blah 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 radian. I am not going to round off because if I round off at this stage, I may end up with a super rounded off answer. Alright, then from here, since I have it in radian mode, I'm going to find out my area of segment with the formula half r squared theta minus sine theta. Fill in the blanks, half r squared, theta in this case, minus sine 7453, so on and so forth. Press your calculator, work it out. You will get 85.5586, so on and so forth. And 2 dp is requested, so 85.56 cm squared in 2 dp. Of course, for those of you who are interested in using the degree to solve, the formula will be area of segment. It is still segment, the shape doesn't change. You will be going 100 out of 360 degrees multiplied by pi r squared, or maybe I should just put it in pi r squared, which is 15 squared, minus away half AB sine 100 degrees. You will get the same answer. Let us look at the next example, where a segment is cut from a sector which has a radius of 10 cm and angle of 36 degrees. Note, the question gives you in degrees. If the ratio of the area of segment to the area of sector is 2:31, what is the area of segment? Alright, let's write down the ratio. We know that area of segment over area of sector. This ratio can be written as 2:31. To calculate area of segment, I know it is 2 over 31 multiplied by area of sector. Since question gave me in degree, I shall do it in degree. If I do it in degree, be very careful which formula you want to use for area of sector. I will go with 2 over 31 times area of sector in degree. That's pi. Oh no, that's not pi. Pi r squared is a full circle. Alright, but area of sector will be 36 out of 360 degree multiplied by pi. And then r in this case is 10 pi r squared. In fact, the question tells you what pi to use. So let's bring this a little bit. It's 1 over 10 times 3.142. The question asks you to use 3.142 only, so stick to the question's 3 pi. And this will give you 21 over 775 in exact, but the question didn't want you to leave it in exact. The question wants you to leave it in 2 decimal places. So we have to do some form of conversion here. And this will give you 2.03 cm squared into dp. Okay, so in quick summary, the whole topic on circular measure, all right, will require you to know arc length, require you to know how to calculate area of sector and how to calculate area of segment, both in degree mode as well as radian mode. So if that is an easy task for you now, let's do some hands-on. Go to the end of the page. You will see the 2 sets of exercises that we can do it. All right, so put them in the same foolscap. This will be your assignment 9.2. Now, gentlemen, please do me a favor. This is not 8B, but 8D. All right, you need to amend that in your notes. So this assignment will be your holiday assignment for your May holidays this year, something unique. Just do this as your assignment 9.2. All right, and then when school returns on 2nd June, we will go through this set of homework. And then that brings us to the end of this chapter. Have a good holiday.